This is a continuation of 8.1. If you need to pause and get a screenshot of this first page, go ahead. And we looked at this example, and we were getting ready to start on this next example. Okay, so on this one, we have to find x bar. And notice that we are given sigma. Again, that's going to be necessary for this section. And we're given our confidence level, but we have to calculate x bar. And what we have is we have 12 samples. We're going to add all these numbers up in any order that you want to. So, for example, 0.24, 0.59, on and on and on, all the way down to 0.32. You should have 12 numbers you're adding in all. Divide by 12. And for x bar, I got a total of 6.31 over 12. And I got 0.5258. And I just rounded that to 0.53. Again, they'll let you know about rounding in homework. In a test, of course, I'll be flexible. And but on the MyLabs Plus, they'll let you know. Okay, but if you're doing MyLabs Plus, let's say, for example, you are taking a test and you did the problem correctly, but maybe you didn't round as they ask, let me know, and I'll see if I can give you a partial credit, because I know MyLabs Plus is very picky. Okay, we've got our formula, which we used up here, and we're going to use that again. And so my estimation for my population mean is going to be x bar plus or minus. Now, the z at alpha over 2 for the 99% we wrote up here is 2.58. We've got that written down, so we don't have to keep looking that up. We've got sigma over the square root of 12. That's our n. And again, I did a pretty good bit of rounding here. And so my lower value I would subtract these two and put that over here. 53 hundredths minus 28 hundredths is 25 hundredths. And for my upper value, I would add those. And again, what I'm saying with a confidence interval is I am saying I am 99, in this case, 99% confidence that this range contains mu. Now, strictly speaking, another way you could say it, and again, if you want to take a screenshot of this before we move on, I would say I am 99% certain or confident that this interval contains the actual value of mu, or more strictly speaking, I mean, if you really want to say it right as a statistician, if repeated samples are taken, because in these cases we're only doing one sample, and we find the 99% confidence intervals for each, I just put CI, .99% of those intervals would contain the true value. The true population mean. Okay, and like I said, this is very simplified here. That's certainly a fine explanation with me, but this is really technically more correct to say. Okay, let's go to the last one here in 8-1. And if you notice here, they've already given me the sum, which saves me adding this up on the calculator, because X bar is my sum divided by the number of things I've measured. So 113.97. And this is in investments in millions of dollars. And I'm dividing by 18. And so for X bar, I get 6.33. And again, at any point, you might want to stop the video and try to work it out yourself and then go back and check it. And like I said, this is in millions of dollars. And so my estimate for my population is 6.33 X bar plus or minus. Well, my Z-score for this one, the 90% I had on my previous page, is 1.65. And that's times sigma. And again, I keep saying sigma known because in 8-2, we'll have sigma unknown, and we'll have to do something a little bit different over the square root of n. So that's 6.33 plus or minus. I went ahead and got a decimal for all of this here. Oh, excuse me, my decimal's in the wrong place, 0.79. And so my interval from u, subtracting those gives me 5.54 millions of dollars, and adding those gives me 7.12. I'm 90% confident that this interval contains the population mean.